course, right after I finished my service. It was with Dr. Stangosu, which some of you are probably familiar with. And then I even, then I went to go work for a few commercial operators, queen breeders, actually queen producers in Hawaii. I was out there for 5 years. And then I actually left working for one of them to pursue apitherapy, but at that time there wasn't a lot of trainings. Like this was actually in the, late 90s thereabouts. And so I was going to enroll in traditional Chinese medicine school so that I could learn acupuncture and then sort of translate that to apipuncture. But then I kind of went down the rabbit hole with queen breeding, and I'm still trying to surface out of that. But it's a fascinating world. And so that's kind of what I'm going to talk to you guys about today. Tomorrow I'll talk to you a little bit more about an apiceuticals, I like to call it, which is some oregano honey and some research I've been doing with some folks in New Mexico, which is my home state. But today I'm going to talk to you a little bit about the history of bees in terms of how they arrived here in what we call the New World, on this big turtle island here of the United States or North America. And then I'll talk to you a little bit about some of the breeding efforts that and collaborations that have come about that I've been able to participate in. So with that, I'll get started here. Let me find the pointer, and I'm going to start my timer because I have a tendency to go on and on. So anybody can get that shepherd's crook and pull me off if we need to. All right, so yep, I'm going to talk to you guys. What I like to call it is bees and seeds. So what I share with folks is that when I try to explain queen breeding, especially to folks who aren't familiar, they go, well, what, how do you do that? What does that mean? And so I equate it in sort of a metaphor, a metaphorical way, which is it's akin to seed saving, right? Depending on where you live, in what zone you're at of hardiness for plants, whether you're in the lowlands or the highlands or your Mediterranean climate or your alpine or what have you, different seeds do well in different places. And so the same actually goes for various organisms, right? That's why we don't necessarily find heliconias or tropical plants growing at the top of Mauna Kea in Hawaii. We're actually a little bit down lower, right, on the wet side of things. And so the same goes for bees. And so I always tell people, it's like seed saving. I try and find different strains from like-minded beekeepers who have similar breeding programs to my own, which I'll describe later. And then I test them out in different areas, see which ones can naturally survive on their own, of course with management. By no means am I promoting hands-off beekeeping or neglectful beekeeping, but trying to find the ones that are adaptable or able to adapt and that remain healthy. And so with that, then I share them once I'm able to start producing them. And so it really does take a community to do that. And as a bees and seed saver, it's nice to meet other beekeepers who are interested in that sort of aspect of it too. So we'll get started here. So this first slide is actually from Sylvania. I wear a few different hats. I have my own farm, which is Zia Queen Bees. I've had that since 2005, and it's been one heck of a roller coaster ride. It's farming. We've got changing weather, and we've got all these interesting challenges. For those who have bees, you guys are very aware of some of the challenges, and I'll talk about some of them today too. And then I'm also a writer, so I serve as the editor for the Cali Beekeeping newsletter, and it's free. It's online, so I'll share that link with you all later if anybody's interested. And anybody who has interesting stories to share, we'd love to publish them. So keep that in mind. And I'm also a mother of two who, as I mentioned before. But I recently, after being 21 years in the field and lifting really heavy boxes, I decided to go back to school. So I'm a researcher of sorts as well, and I'm working on my master's right now at Washington State University at the Shepherd Honeybee Lab. So these first slides are actually from Dr. Shepherd's sort of historical analysis of bee and bee genetics that he shared with me. And I'm going to share them with you all. So part of this story really, the journey begins as any immigrant story would, which is, conflicting evidence, not so much evidence, but conflicting sort of historical aspect is that, honeybees aren't native to the Americas. There are fossil records, though, that they have found in Nevada that show that there were cousins here. But like many of our ancestors in this room, honeybees are immigrants to this country. So we'll kind of start with that here. Is this turning? Where do I point at? I thought I was pointing the right thing. Okay. All right. So some of the consequences of colonialization, right, is you're only able to bring in certain things at a certain times. And way back when, we're talking pilgrims, we're even talking some of the conquistadors as the Spanish came up in and, brought some of these old world stocks as well. But they were only able to bring a few things, just like seeds, bougainvilleas, other plants that sort of were brought in by our ancestors. And over time, that became more of an issue because, it wasn't very easy to transport honeybees on ships. And then there was the advent of the steamships, and that kind of brought some more in as well. But it all really sort of changed over time with just how many people were bringing some in. And then people started producing them in the New World, so they weren't necessarily bringing any more in. And so those types of genetics just sort of became stagnant to a sense. Next slide, please. So as we know, honeybees are pretty diverse in terms of their subspecies abilities. So they're all the same species, right? Apis mellifera, but then you have Apis mellifera linguistica, Apis mellifera caucasica, and I'll talk a little bit more about that. But they all sort of adapted into what we call these ecotypes, and they're able to adapt to different landscapes. Next slide, please. So this kind of shows the distribution of the genus of Apis, at least the endemic strains here. And then next slide, there we go. So here, this is showing there's 28 recognized subspecies of Apis mellifera. And these are ones that are endemic to the Old World, what we call OW. You'll see that later on. Here's a few slides of those. So Apis mellifera mellifera, which is in Spain, France, parts of Germany, North Italy. Apis mellifera linguistica, which we also tend to call Italian bees. Carnica, and I think, did it show caucasica? Yeah. So a subset of the known species were brought to North America, and they form the basis of current populations. Next slide. So they got brought over. And so this is kind of just showing here when they arrived in the US. Okay, so starting a while back, but, and then it kind of stopped for a while. And part of that was because in 1922 they had the Isle of Wight disease, is what they called it, and it was actually tracheal mite, and so they shut the borders. And so basically then it was illegal for anybody to bring any more honeybees to the New World. And so that kind of also is attributing to some of our genetic sort of bottlenecking that we've experienced today in the industry. Next slide. So this is kind of showing here within the US, and some of you may already be familiar, but can anybody share why they think there's these concentration of queen producers in these areas of the US?
Climate.
Yes. Climate. There we go. So these tend to be warmer areas, right? Southeastern part, and then of course the West Coast. So they have a jump on the season compared to the rest of the states. Next slide. So this is showing some queen cells here. And this is a slide that I've actually put together just for those of you who aren't familiar, kind of walk you through this process. So it starts at the top, goes clockwise, zigzag a little bit, but you find your select breeder frame from breeders that you've selected, whatever your reasoning is for that, and I'll share more what mine is. You find the appropriate age larva. There's different instars, so they're molting each day. You have to find the right age. You transfer that, they get put into cell builders, some people call them starter finishers. That takes you to the middle picture there, the cocoons, the queen cells. They have to be handled very carefully and then placed very carefully. And then a few weeks later, you'll have a mated queen that you can then harvest and either share with other people or let them grow into their own colony. So next slide. And there's been some issues with not only the genetic stock that's available, but with also some of the production methods or rearing methods from conventional sort of industrialized beekeeping situations. And so we've had an increased concentration of queen production. And basically what that means is, as we saw on that map of the US, you just have certain areas where it's really sort of concentrated, and those folks are just pumping out queens with the same genetics year after year after year. And regardless of where they get shipped to, they're still just pumping out those same genetics. So, you know, if you get queens from Georgia and you're living in Michigan, you know, there could be a chance that they can't survive the winter. So next slide. So this is just kind of showing here of, you know, all the queens produced, only 603 queen mothers were used for that. That's devastatingly low, you know, because this is for nationally, you know, national distribution. Next slide. And then now this is for 2004 to 2005. So these slides are a little dated, but it shows you, and it's actually getting a little, you know, has gotten a little bit worse, and I'm about to show you how it's going to get a little bit better. So some of the effects on these production beekeepers is, you know, it minimizes the diversity of the strains that they have in their operation. And when you get pigeonholed into only one sort of genetic pool, where the alleles are not necessarily as diverse as they could be in nature, then you start to get inbred situations, and that can really affect the health of bees. So I'm sharing all these slides with you today because whether you are a beekeeper or not, if you are definitely using hive products, you're harvesting these products from bees that have this whole history here. And that's important to us to realize where these bees have come from, where they are now, and where they may need to get to, or how can we help promote healthy situations for them. So herein lies the situation of the recent collections. And so these are slides from Washington State University I'm going to share with you guys. And so they're one of the few labs that has a permit to bring in honeybee stock. They're actually, because of that law, the 1922 law that disallowed importation, they are not allowed to bring in honeybees, but they're allowed to bring in semen. And I used to, for many years, be kind of on the fence with that because it seemed a little bit too much to have to deal with the bees. You know, they mate on their own. Why do we need to get our big paws in there? But it is a breeding tool, and because of this law, there really is no other option unless you want to sneak them in and face jail time. And heaven forbid you bring in something as well that could be carrying some sort of virus or some other sort of detrimental trait that could devastate all of our quote-unquote localized populations now.
It'd be interesting if you say when last time the United States really allowed to do that.
When they were the last time allowed to bring in semen?
No, bees.
To bring in bees? Oh, well, I think it was, Australia. They brought in a bunch of packages from Australia a while back for almond pollination.
I think that 15 years ago.
Breeder queens. Yeah, it's been a long time. So next slide. So this is just showing here some of the imports that WSU, and this is specifically Dr. Shepard. Some of you may have also heard of Sue Colby. She also is a part of this sort of endeavor, and Dr. Brandon Hopkins, and there's pictures of them later on. So this is just showing where they went to get semen from and to bring it in. And the reason they chose these places is because they were looking for bees that could overwinter well. They were also looking for, in the old world, and they were also looking for bees that had already been exposed to varroa that may have already natural defenses or genetic properties that are enabling them to coexist with varroa or to cope with varroa. And it was their efforts to try and bring this in because they thought if we can bring in genetic stock that has these traits, that are resistant or resilient, then it could help prevent beekeepers from having to apply so many either miticides or caricides and or antibiotics or whatever other quote-unquote therapeutic concoctions in order to keep things as pure and natural as possible, right? Because even if you aren't necessarily treating for varroa, or if you are treating for varroa, you know, varroas are serving as the vector. I'm assuming everybody here knows about the varroa mite, but if not, I'll talk about it a little bit more. So it's a bad bug that affects the good bug, so to speak. And they're vectors like mosquitoes, and so they transfer diseases. So this is showing here the process of them bringing in the semen in terms of how it's collected. The top picture is actually of a drone that's been averted. Okay, so that's the phallus there on the end. And they're collecting the semen off of it. That's the marble sort of colored stuff. And then it gets in, inserted or inseminated into a queen. This is all done under a microscope. It's pretty tedious. And these queens are actually, they've been, I don't want to say gassed, but they've been given a little bit of CO2 so that they're not awake during this process. It's actually pretty interesting. I mean, like I mentioned, I kind of did a 180. I used to think, oh, this isn't a very nice thing to do, but these queens afterwards they perform beautifully, and the whole point is that it's not so much that you're trying to create a better bee, you're just trying to get the seeds that they have and be able to share them with beekeepers who can then use them for open mating in a natural process. So USDA actually requires that they have a quarantine area, and so Eastern Washington is a very actually terrible place for honeybee forage. It's all wheat. They call it America's Little Tuscany. It is pretty when you see these amber weights of grain, but in terms of bee forage, there's not very much. And so it's not very good for forage, but it's a pretty good place for isolated breeding because there's not a lot of feral hives around that area. So some of the benefits of them bringing in this germplasm and of the use of cryogenics, which I'll talk a little bit more about, is that they're able to access the original honeybee stocks from the old world, right, where they're endemic, and share those with beekeepers here. And it's a selection across time, so they're able to do this within one season. You know, the first sort of insemination that you do, you're not going to come out with a 100% Caucasian queen. But through back crossing, you can get to near as close to the original stock. And there's a couple slides showing this. So Dr. Hopkins, he's now a professor and his teaching assistant for his general entomology class. He does a lot of really cool research. Some of you guys may have heard recently too, and I'll talk about this tomorrow, but the mushroom and bee sort of story that went viral, this is the lab that's working on that, and they're really awesome folks. So one of the reasons I took a sabbatical from my farming to go pursue a degree here, I mean, it had to be a really good program, is that they do a lot of interesting research using what we would consider progressive or alternative approaches to conventional management. So they're trying to figure out ways to support beekeepers through more of a natural process versus, oh, let's patent this new synthetic concoction that'll make a super bee. They're very much the reverse of that. So here we go. So this is just showing now, once they bring the semen in, they're also now developing a seed bank. So some of you may have heard of that nice seed bank that they're doing up, I think, in Norway. So the same thing is happening now with the pollinator semen, or at least with honeybees that they're starting with. The USDA just started a U.S. germplasm repository program specific for honeybees. So once they freeze it and they thaw it out and they inseminate, the brood does not look that good. For those of you who are familiar, this is not that good a brood. But whatever viable brood they do have, they're now able to get daughters off of that. And then the next slide, it gets better each generation that they reproduce. And the whole point I mentioned is not so much so that they can make a super bee, it's just so that they can bring in some of these genetics. We rear, actually, I'm in charge of their summer rearing program. And we rear around about 300 queens a year that then get shared with other producers who can then use those as breeders to make many more to then share with beekeepers all over. Next slide. So this is them. They went to Georgia to get some Caucasian honeybee stock, which is from the Caucasus Mountains. They're actually very dark bees, despite the name. And go ahead and show that. So this is just showing you what I was kind of mentioning here about back crossing. So if you keep going, just keep pressing the arrows here. And they do a graft, 50% of the first generation. And then if they're able to start in April, as if the weather's good, each time they can back cross it, if they're able to get 6 generations in the summer, then this is how they get as close to the original stock as possible. So about 97% then by the end of the summer will be Caucasian. This is the repository program that I mentioned. And in 2015, they went to Kazakhstan and got Apis mellifera pulmonella, beautiful bees. They're black and white in the integument, very interesting. A lot of pubescence, which means fuzz on them. But they chose these ones because this is an apple region, and Washington State grows a lot of apples, right? So They're looking for stock lines that can help people who do pollination in particular crops, but that can also overwinter well. And part of that is so that beekeepers also don't have to rely on a lot of these southern states for finding strains that work good where they're at. These are just some shots there from Kazakhstan. I love those pictures of the hives. So this is Brandon actually collecting some drones. They wait till the afternoon when the drones are taking their orientation and mating flights. Some people may not be aware of this, but when you see drones, they're not immediately sexually mature. It takes about 2 weeks to 20 days for them to become sexually mature after they emerge. So when you see drones crawling around on the frames, those are usually the juvenile drones. It's not until you see them out in the front, or actually out flying and coming back, and they're taking orientation flights, that then those are the drones that are ready to mate. So this is just showing a few different steps here. Once they're collected, then they can collect the semen. And this is Jackie Park-Burris on the left in the white shirt, and then in the blue shirt on the right is Sue Colby. Jackie Park-Burris is a California queen producer. She's really big on the Langustica or Italian bees. And she's one of the bigger proponents for this repository program because she's a 5th generation beekeeper, and she often says, wow, if I only had the stock that my great-grandfather and my uncles had when they got our bee program started. And she feels like it's been lost. It's been lost because the gene pool got contracted and really got bottlenecked, and only now is she able to go and start bringing semen in. And when it comes in, they can't use it right away. It has to go to the quarantine yard. But before it even goes there, it actually has to be screened. The semen has to be screened by the Beltsville, Maryland lab for viruses because semen can carry virus, as can eggs and larvae. So these are just some cool pictures from their trips. And so they're trying to measure the impact, like how is this benefiting American honey producers? And some of this here gets a little technical, but it's just talking a little bit about the alleles in terms of the genetics and how some of these have different sort of sites on the chromosome depending on the locus. So this is an interesting slide because they're showing out of 240 colonies, right? 127 were Old World from Europe, 113 were from California. When they looked at those, 95 of the alleles were unique. 75 of them were shared, right? But 95 of them were unique. So there's 170 total, sorry, I forgot to mention that. So it's just kind of breaking that down here and showing that even in the Old World, within these subspecies, they have a lot of diversity even within their subspecies. They haven't had the bottlenecking. Even though you would think it's more of a single race or strain of bees, they still have a lot of diversity just within their own subspecies. And we don't have that here in the US.
Can you elaborate why?
Part of that is because of the fact that we haven't brought in more. Part of it is also because the producers have routinely selected off of the same mothers over and over. So it kind of goes back to that slide where they're only using 603 mothers to make over close to 900,000 queens. And that's part of the reason. Yes?
Any viruses in particular that you guys are looking for the germplasm?
That is not my specialty, but it's Dr. Jay Evans is the one who spearheads that. I know that they check for, I think, at least 24 different viruses, but I can shoot them an email to double check which ones they are. But I know that they're looking for, Israeli acute paralysis, they're looking for cashmere, they're looking for deformed wing virus, they look for all the things that they think may affect our bees here that they know of. There's still a lot of these viruses that are they're trying to identify. So they're not able to check for the ones they don't know, right? So this is just kind of showing here the different subspecies groups. And these are sort of the alleles and how they pan out. But this is what's really interesting here, is you can see that the California ones are all grouped together. They're all really close because they're all inbred. The rest are spread out because they're unique and distinct. And so this is showing too within the WSU program, there's a little bit more of a spread there than within the California producers. So one of the things about this whole germplasm approach is that it's It's a way to access what Mother Nature has already sculpted and crafted over thousands of years. And being able to sort of pull that into present day to share with beekeepers here in the New World. So this just kind of shows some more info. This is the young woman who did a lot of this work. Her name's Megan Taylor, and that's Dr. Shepherd right there. Megan Taylor's actually working in New Zealand now. And I think she's working on another publication about the old world stocks that she was able to analyze. So in January 2016, and I already mentioned this, that they started an American honeybee germplasm. So WSU had their own little bank going. They've gotten a few grants to get the tanks and all that sort of stuff. And now the USDA has decided to support that effort. And I actually got to go to the initial meeting. And in Fort Collins, Colorado, there's an underground vault with these huge tanks where they have germplasm from all sorts of livestock, whether it's Angus bulls to heritage turkeys to all sorts of things. And it's very interesting because, you know, with bulls and other larger organisms, you know, let me just put it this way. Bulls have about a quart of semen, okay? Drone honeybees have a very tiny little straw. So we can fit a lot in one little tank versus all these other organisms that each need their own tank. So it puts things in perspective when we see it in comparison to other organisms. But it's behind lock and key and it's underground. I was really sort of surprised by all of that. And the reason for that is it's just a bank. They're not planning, you know, that they're actually developing the program so that it's not like nobody will have access to it. They're trying to figure out who can have access to it and how they would go about it. But it's going to be an open bank. It's just they don't, you know, what they don't want is to say, okay, yes, we'll share this semen with somebody, and then that person takes all this semen and then puts a hold on the market, and they're the only person that has it, and they're going to charge you thousands of dollars to get it. They want to make it more open source for everybody, so that everybody will have access to good quality natural stock that they're able to use to adapt to their particular situation or their region. So that's Dr. Hawkins. This is just a drone flight cage. They're at Jackie Park Burris's place. So here's some of the benefits of that: enhancing the genetic diversity, providing new raw material for selection, and the reintroduction of previously available cold climate adaptive strains. And that mentioned Caucasian, but I mentioned they're bringing in Palmanella now too. So there is a widespread agreement that breeding is our best option to select for pest and disease resistant. This article came out just this past week, which really freaked me out. Maybe it was last week in The Guardian. And it's called Transgenic Bees. I don't know if any of you guys have seen that. It's, I find it slightly disturbing. Because, yeah, I mean, do we really need to go in there and genetically engineer a bee? I'm not so sure about that, especially if Mother Nature has these other resources for us that she's been sculpting, as I mentioned, and we can just promote that. It's a process of preservation and conservation, okay? So they're going to continue these breeding activities. Those are the big tanks I was telling you guys about that are underground. Go ahead. These were the first two to get their semen in the tank, and I can actually say I was the third one to get my semen in the tank. I never thought I would be so excited, but it's like, wow, this is like a moment in history, and it's from my home state. These are bees that were sculpted in the Rocky Mountains, and so it's now preserved in this catalog for future generations, and to me that's kind of special. So here's just a little summary of that, kind of reiterating all these things, and they're going to be looking to go to places. Can you go back to that slide? Sorry, number 2. They want to go to places where bees were introduced, but that have been maintained through selective breeding. Okay, they don't want to store semen from doped up bees or bees that have been crunched with antibiotics year after year. They want to collect and preserve the stock lines that are naturally resilient. So if you have really good bees that have survived multiple years, let me know, because we are avidly going to be starting to go around and visit beekeepers across the U.S. You don't have to be a big scale person, but it's good to have records so we know what you have, and try and preserve these really good stocks that people have. So next slide. All right, so they're going to continue that. This is them coming to pick up some of the breeder queens that we were able to share with them from the WSU program. That's Jackie's operation. That's immense. I think I have maybe like an eighth of that in my own operation. But size doesn't matter. But it is kind of true. You know, WSU cannot make thousands and thousands of queens. They're just not equipped for that. Okay. But if they can make a few hundred and share them with producers who do have that potential, it's not so much that they want to promote large scale, but they want to be able to get it out to as many beekeepers who are interested as possible. And these larger scale producers are able to do that. Okay, I'm running out of time, so I'm going to talk to you guys quickly about my own breeding stuff. So if you want more info on the WSU breeding program or the American germplasm program, you can check out the bees.wsu.edu and Dr. Shepard. And I mentioned this is also on your thumb drive. So ecosystem services, pollination is on here, but all of these things are what Mother Nature provides for us. And so I like to call this section, you know, a queen for all seasons and how to develop strategies for promoting healthy hives. I'm a quote-unquote treatment-free beekeeper, though I do practice some herbal therapies for my bees when needed. But yeah, I'm really more of the mindset that, you know, whatever goes in the hive is going to come out. So do I want antibiotics in my hive? Because then I'm going to have antibiotics in the honey. Me, no, I do not. But to each their own. But in terms of using them for medicinal purposes, especially with this audience here, that's important for us, right? I mean, we want pure, we want as clean and as healthy as possible products from the hive. So back one slide, please. Sorry. This is a really cool article here, and we'll breeze through it. But COLOS, for those of you who haven't heard of it, it stands for colony loss. And it's actually a global consortium of researchers who are working on figuring out different aspects. Really cool information they have about honeybee genotypes. So this is the information that I was waiting for, because here I am sharing my sort of vernacular field experience, and then all of a sudden now science is catching up and saying, oh, it's true. Bees that are acclimated to a certain area do better than bees who are not acclimated to a certain area, right? Okay, so this just kind of talks about those papers. There's actually another one that gets listed here. And yeah, we'll kind of breeze through this just to get you to the good stuff and keep on time. But they did start a task force on sustainable breeding, which I think is really exciting. And it's breeding.net, so you guys can check that out. And mainly it's just this interaction between genotype, meaning the genetics, and the environment. So now we have the phenotype, meaning like the actual physical representation in this place, sense of place and a sense of purpose, right? So again, it's just specifics on that, and you guys can have that on your own. But it does confirm the higher vitality of the local bees compared to the non-local ones. So, and this is another paper here, so you guys can check that out. But this all does still revolve around these natural processes that you know, Mother Nature provides for us. So, or these ecosystem services. So, I'm sorry, my alignment's a little off here. So the ecosystem, you guys may be aware of that. And then next slide. And how that changes from season to season. I shared this slide because beekeepers, it took me a while to figure this out when I first got started. But you know, depending on your landscape, depending on the time of year, it's going to dictate what sort of forage you get. But that forage is going to ultimately dictate the nutrition and the health of your hive, right? So if you're in monocrop agriculture where they're doing a lot of spraying, the nutrition that your bees or any pollinator has access to is really going to be severely compromised. So, biomimicry or mad science, I like to think that for sure is a sense of inspiration and how we can reconcile this sort of compromise here with working with the landscape to help our bees to adapt, right? I mean, they can do it on their own, they've done it for a long time, but then, you know, industrialized agriculture came in and kind of, I think, blew a big hole in that boat. And so I think we do have a sense of responsibility to do what we can to manage our bees appropriately, or to at least support them in doing what they need to do to survive. So within the US, you see we have, of course, here, I mean, this is grade school stuff, but I put this up here as a graphic relief map just to kind of show you just the diversity of not only the topography, but also the microclimates that exist, right? I mean, within this one country, we have everything. from desert to tundra and then some. And we've got tropical even, swamps and marshes. So. And we're experiencing a lot of issues. A lot of it is weather-induced, whether it's drought, wildfires, water contamination, all sorts of things. But any organism that can survive through time, like the seeds, right? They have this genetic history, and these that have been sculpted over millennia, and they're also able to keep adding these stories. And so they are worthy of sharing. So this is kind of getting to the title here. The seeds the bees are like the seeds. And so Queen for All Seasons, this will just kind of breeze through here what I've done with my breeding program and some collaborations. So I kind of take it a step further. I start with site specific where I'm at, but then I also share bees with different beekeepers and then ask them to tell me, how does that work for you where you're at? Oh, you have really good stock. Maybe I can make some daughters off of those. Maybe we can do a cross. Let's see how that works and let's share this. So I call it, honeybees chosen by beekeepers for beekeepers. I'm sorry, go back to that last slide real quick. I love this shot because the pollen there, that just looks so delicious. And you see that rainbow of flavors, right? And you know that they're getting some diverse nutrition in that. That protein content there is varied. And that's healthy, It's healthier than just having only one color, only one kind. Like having only Wonder Bread, right? We all kind of get sick if that's all we ate. So trying to keep bees healthy from season to season. And I take a lot of pictures, as you guys can tell, but especially the hexagon is so symbolic. So I kind of consider it to be about 6 different facets to rearing good queens. You have breeders up at the top, which we can't read that well. The cell builders are the nursery hive, your grafting, or however you're going to actually transfer your cells or get them to pull queen cells. Your mating nuclei, how you handle those, and then whether you're catching, harvesting, baking, shipping queens, all that sort of stuff. Each one of these steps could be compromised, and it doesn't matter what kind of genetics you have. If you compromise any one of these steps, you sabotage those genetics. So herein lies the other equation with these larger scale queen producers who I learned off of a lot of them, and I have a lot of respect for anybody who decides to keep bees as a profession because it's tough. But if you have really good genetics, but then you rush the process, the receiving party is going to be the ones who pay that bill, right? So I equate it to like having unripe fruit, and it gets plucked, and then it gets shipped halfway across the world or across the nation. Your bees are going to know that that's unripe fruit. She doesn't smell right. She's not laying properly. She was picked too early. She was harvested too early. So we're working a lot now with producers to try and encourage them to extend that. And there is research that shows that that's coming out with Australia and also the Tarpey Lab in North Carolina. That does show, when queens are produced, if you pull them too early, you kind of shut down their whole reproductive abilities there. So this just kind of shows all these sorts of different things that go with that. Some of the proactive potentials. So I call it survivor stock. I kind of quit using that word now a little bit because everybody and their brother was like, well, my bees survived a month. They're survivors. No, that's not true. And so I go more with longevity-based breeding program. I pick my breeders after they've gone through at least 2 winters, have remained healthy, no treatments, are gentle. I like having gentle bees, and can overwinter well. I'm at 8,300 feet in the Rocky Mountains. So I actually have a shorter growing season than the Upper Peninsula of Michigan by 1 day. And that really does require some really hardy bees, right? And then I test them out in different places. So this is my farm's little story on how we do that. So from the shores of Lake Superior, my farm partner, Mark Spitzig, I always have to mention him because he's the wizard behind the curtain, and he's taking care of the bees while I'm here doing this. So that's he deserves props for that. And then to the banks of the Rio Grande, that's kind of been a little motto here. So the picture on the right is actually of Truchas, New Mexico. That's my home base. And yeah, you can tell that that's at elevation because we get some good snow. Truchas means trout, so if any of you are into trout fishing or what have you, you can come on up to visit. But it's a really beautiful place, and it's isolated to the extent that that region, and also the range across near Los Alamos, they call them sky islands. So they're up high and they're kind of isolated. So I don't necessarily have to do inseminations, and I call it instrumental insemination. I don't like to use artificial insemination because the semen is very real, it's not artificial. But I don't have to do instrumental insemination where I'm at because I have isolation on my own just from the topography. So that's kind of how I go about that. And go ahead and show some more slides here. So, back one. So for us, when you're choosing for longevity, you can choose for a few different things. Pest disease resistance. Over time, you can see that. Hygienic behavior, you can make, there's going to be ebb and flow with the mite counts. Sometimes they're high, sometimes they're low. Some people see them when they're high and they freak out and think they have to do something. And then other times they stay low and they don't do anything, and then the next time they check, they've skyrocketed. So it's becoming more and more complicated. And you can either try and play that like treatment, treadmill game. I always tell people, try and hit it first with good genetics. And with how those good genetics were produced, and then you're going to be able to really, that'll dictate, and you'll be able to see how then you're going to need to manage, right? So if you have what some people call puppy mill bees, I don't call them those, but if you have some of those, packages, they're easier to get, they get delivered right to you, they're inexpensive, that's why a lot of people get them. They may be reared in different circumstances, so then, people go, well, I wasn't going to, I was going to be treatment free, but then they died. And it's like, well, yeah, because those bees may have come from a chemical treadmill background. They have no idea how to survive without intervention. So that does change what your management's going to be if you start with bees from those sorts of backgrounds. So this is actually just a slide talking about, Mark took a class from Dr. Marla Spidik, University of Minnesota Bee Lab, back in, I think, 1997 or so. And it was called Beekeeping in Northern Climates, but she said at that time in their area, what they noticed was that if you did not treat for Varroa, that your hives would crash within 2 years, or 18 months is what she had said. So for him, he thought, well, he first got started, he got this fancy kit that had all this antibiotic stuff, it was like the bee health kit from one of the bee supplier catalogs. And he said all the fine print really freaked him out. And he thought, well, I'm new at this. If I lose a couple, it's gonna hurt, but I'd much rather try to do it without that because this fine print stuff really scares me. I don't wanna have to use that stuff. And so it just became a matter of practice when he was, making his own splits, was he was gonna make them off of the ones that were at least 2 years old, maybe through 2 winters. So you can just kind of go through these slides here. I know I'm probably running out of time, but I call longevity the umbrella trait because I borrowed a term from the cattle industry, the OLM, overall lifetime merit. To me, this is not like a new idea at all. It's very common sense. You just breed off of the ones that can survive, right? So just kind of showing here environment locations. So for those who don't know where New Mexico is, I'm just going to point right here for you guys. It's right here. And yeah, as I mentioned, we've got desert to tundra. So strive to maintain lower levels, and we try to integrate hygienic stock. We track our queens, so there is an international color code. I use a water-based, non-toxic, non-odor paint. That way I can keep track of the year. So I put a plaque on the front of all my hives, and that way I can pull up to any bee yard and just see visually without having to open them. Oh, she's 2 years old, she's 1 year old, she's however old she is. And then when I get ready to graft off of them, I double check to make sure she has that color coding. So after doing this for, I said 21, I guess 22 years of reflection is having good stock, finding good spots for them to have, as much natural nourishment as they can, good record keeping, and then of course how you handle your production. So next slide. And this is just showing that process again there. The other thing to keep in mind too is it's not just the queens, it's the drones. So you saw in the first half of the talk that this sort of selection process, when we're bringing in semen, there's diploid and haploid. Workers are diploid, meaning they have 2 sets of genetic information from the mother and the father, right? But the males only have their mothers. So they're technically not clones, but it's a metaphor for what they could be considered. They're clones of their mother in terms of the genetic information. So if you have really good hives that you like, you really actually want to make sure that you promote their drones, because they're the ones who are they're the seeds that get casted out there to go spread those good genetics. Go ahead. So this is just showing you how to communicate with everybody. Couple projects we did in terms of working with local beekeepers. Next slide, please. This next one was, yeah. So we just worked together to do this, and it really does take a community. You can kind of go through these, kind of showing where we stand. It was, that project in particular was close to 500 miles. We did a pretty extensive thing. It was good and bad. We had some good experience and some bad experience with that one. I learned a lot with that, but these are beautiful things. So all of this is on your thumb drive, and you guys can look at that at your leisure. And I'll be here through tomorrow, and I'll be talking tomorrow. So very glad to be here.
Thank you.
Thank you.